I hope we're all doing well. Last week we were able to cover up to AWS CLI, and then I gave the Cafe CLI as an assignment to you guys. And then for the rest of the topics under Systems Manager, Administration Tools, AWS Compute, managing EC2 instances, Beanstalk, I think S3, hosting a static website with S3. You joined Aminu's class for those topics. So I just want us to have a recap of some of the concepts that we saw yesterday. So irrespective of if it was in my class or it was in Sir Chumesi's class, as long as it was something we treated last week, if anybody could tell us what they learned or what they remember from our session last week. Hi, Calvin.
Hello, Akusha. Good afternoon.
Good
Okay,
afternoon.
we learned about how to use the CLI to create IAM users on a Windows using the Chocolate.
Okay, so you installed the AWS CLI on your Windows machine using
Yeah,
Chocolatey.
yes.
Oh, okay. Thank you, Calvin.
Oh,
Hello, Dennis.
Hi, I was here. Good afternoon once again. So,
Afternoon.
for me, Sejumesi's class was very, informative with a vast amount of projects that were demonstrated. And I think one that I was really impressed with was Mr. Odum's presentation on provisioning instances and adding up the load balancer and what do you call it? Um, oh, forgotten the word. What
Autoscaling group.
autoscaling good, thank you. Yeah, it was quite a comprehensive one and an impressive one. I also learned a new service, which was the AWS pipeline, where another group used it to demonstrate how you can set it up with your GitHub so that automatically when you push your code, it's able to just update and then upload, deploy it into production without you having to touch anything. Like it was just automated. So that's also something I learned from last week's class.
All right. Thank you, Dennis. So yeah, last week, Victoria, John Harold, Dennis, Ima, you guys did a good job with the presentations that Aminu handed out to us. And I believe is Osman here? Yes, I believe Osman was responsible for the tweaks that Victoria was able to make on their projects. So
Yes,
I
madam,
was
yes, good afternoon.
Hi Osman, how are you? Yeah, so I was able to join some of the sessions. So I saw how well you guys did, and as Dennis mentioned, Ima did really well. So when the presentation was going on, you could tell that it's something that he's practiced and then something that he does. And those are some of the things that would make you stand out, especially when you go for an interview. You might be demonstrating something or you might be talking about your experience, but in the way you will talk about it would show those you're demonstrating to if you like really know your stuff, how well you know your stuff, things like that. So I noticed that with Ima, Aminu had to ask about if it's something he had done before and then those things. So I just want to encourage all of us that we should strive for That's kind of excellent, okay? So even without we speaking, or even without we saying that, okay, we've been doing this for 2 years, 3 years, just in how we work and how we go about our tasks, people should be able to tell that this is something that this person does. And second. Yeah, so with Amino's classes, I noticed there was a lot of demonstrations. So I just wanted to know if any of us still went back to the slides to do any reviews, or the understanding that we got from those sessions were enough for us.
Yeah, so for me, I've still gone back to do the portfolio. I've tasked myself to like work on a portfolio and deploy it with the S3. So it's still a work in progress that I'm following the material to do. Yeah.
Okay. That's excellent. So, if we are able to continue on this path, by the time you'll be done with the program, you'd see that, or you realize that you'd have a lot of projects that you can talk about and you can show when you start to apply for jobs. Okay. So I just encourage all of us to build these projects. So because you are kind of new and you don't yet have experience, so it's your projects that are going to speak for you. So I encourage all of us to go ahead and build some of these projects and document them accordingly. Okay. All right. So the topics that we treated last week, we've spoken about the CLI. We've spoken about well, auto-scaling groups are this week. So we've mentioned auto-scaling groups. So please, which other concepts do you remember from last week? I know there was a systems manager demonstration by one of our Aminu students. What do we remember from that session? Or what's the use of systems manager? Dennis.
Yeah, so from the demonstration, I got to understand that the systems manager can be used to manage your instances, like multiple instances at a go. And then it also helps in the aspect of security, because then you don't have to allow SSH ports or whatsoever. Once you configure your systems manager with the instances, you're able to log into your instances at once, like multiple instances at once, perform any updates that you need to do, and any other form of management right from the systems manager. You can also see some metrics on the instances, how it's doing, the memory management and all that right from there.
All right. Thank you, Dennis. Ima.
Yeah, thank you, Akosi, and good afternoon. Welcome back.
Thank you.
Okay, please. What I remember with the system manager is that it has a lot of utilities that we can use to do a lot of things, especially when it comes to automation. And you can use it to patch your system, your EC2 instances. If you have so many of them, you can use them, or package them into fleets, and then use Patch Manager to patch them. You can also run commands. Yeah, you can also run commands. You can also, like Dennis rightly said, to manage your EC2 instances fleets. So basically, System Manager has a lot of things to do, talking about automation, patching, accessing your EC2, and it also has a session manager where you don't have to go through SSH routes, and by that you can easily get access into your EC2 instance and then do whatever you want to do. Thank you.
All right. Thank you, Emma. So yeah, Systems Manager has a number of sub-services or features which you can use to manage your EC2 instances. So those tasks that you need to be doing repetitively, patching, OS updates, creating images of your, when I say images, I mean AMIs, or even snapshots of your volumes. All those things, you can define them in a document, and then you mention how this SSM document should manage or should perform some tasks for you, and you'll be able to run these commands or run these documents on these multiple instances. Okay, so it helps, it's a good way to manage your instances. Okay, and was there a demonstration on CloudFormation last week?
It was Emmanuel who used it a little in his demo.
So I think they hinted on it or something.
Okay,
Yeah, Emmanuel used it to provision some VPC environment.
okay. So I think we would do that tomorrow. Today we'll look at load balancers and auto scaling groups, and then tomorrow we would run Ime's stack, his CloudFormation stack. Yeah. Okay. Okay, we've already done EC2 and all right, so who can tell us something about Beanstalk? Can anybody aside Dennis tell us anything about Beanstalk? Let me see. Michael Amwa. Last week we came across two two new services that we can use to launch an application or launch an application or launch the site for the cafe project or for any company's business. Okay, so Beanstalk, Light Sale, we already knew about EC2, we already knew about S3. So who wants to tell us about Beanstalk? Yakubu.
Yes, good afternoon, Chris here.
Good afternoon.
Beanstalk is a compute service just like EC2, but the difference between Beanstalk and EC2 is that Beanstalk is more of a managed service than EC2. For EC2, you have to you have to provision a lot of resources like elastic load balancers and then auto scaling. But then for Beanstalk, you don't have to do all this because it's managed. It's a managed AWS service. So it's also a compute service, like just like EC2. Thank you.
All right, thank you, Yakubu. Very cool. So answer.
Yeah, Kusha. Good afternoon.
Good afternoon.
Okay, so a little I know about Beanstalk. That's what I got from the presentation was I know you can use it to deploy your application with just a few clicks. And then also it supports a variety of like programming languages like the PHP, Node, Python, and the rest. Yeah.
All right. Thank you, Derek. So yeah, so the way we know to provision or build an application is with EC2. So we go and specify the instance type we want, the volume, etc. And then we provision our EC2 instance, then we go ahead and then we create the application. We are responsible for getting the web server to use on our EC2 instance. and all those things. But when it comes to I'm going to speak on Beanstalk. So when it comes to Beanstalk, you just specify the kind of application that you want, and Beanstalk takes care of the infrastructure, provisioning, and all of those things for you under the hood, looking at what your use case might require, and then a similar tool or another compute option too that you have if you don't want to get into all of the details of provisioning your EC2 instance by yourself, is when you use Lightsail. And you would also be able to quickly and cost effectively deploy an application. Okay, so for blogs, e-commerce websites, those lightweight or applications that are not so large, Lightsail is recommended for those. Penty.
Yes, good afternoon.
Good afternoon.
Yeah, I want to know if the Elastic Beanstalk also offers container services, because I wrote a CCP today. I had a question concerning that, and I was kind of confused because the closest answer I had was Beanstalk. All the rest was out of the box. So I want to know, does it offer a container service?
Do you remember the other options that you saw?
Not really, but I think they were all out of the box. I think I saw Amazon Connect, Amazon Direct Connect, something about gateway. In fact, the closest one I saw was the
Was
Elastic
Beanstalk. Oh, okay.
Yes.
Yeah, so Beanstalk supports Docker, which is the container registry. So yeah, you can use Beanstalk to deploy container services.
Okay. Thank you.
You're welcome. You said you took the exam when?
Today,
Oh, okay. ALX, their timeline has started.
yes.
Oh, okay. How was it?
It was okay. It was okay.
Okay.
Okay. I didn't see the concept to be really difficult.
CCPDA. Congratulations.
Thank you.
Okay. Yakubu.
Yes, and I forgot to add that Beanstalk is a platform as a service service. Yeah.
All right. Thank you, Yakubu. Okay, so I believe that is it concerning a recap from last week. Does anybody have any questions about some concepts from last week that they would want addressed before we move on to what we have to do for this week? Also answer.
Okay, so mine is a question. I want to know, is it possible the last week, the Friday, the recording, if we can access it, because we only have that of Thursday. I don't know if
All
we
the
can get that on
recordings
Friday.
are on is it SharePoint? There's day 4 and day 5.
I think it came on, I think Thursday evening or so.
Yeah, but the Friday ones are there.
Oh,
Have you
okay.
checked today?
No, not really, but
Oh,
I'm yet
okay.
to buy this one.
So open day 5. I think one is on S3 and Beanstalk, and then the other one is on some other topic, but then they are there in the same drive that Aminu shared with you guys through email.
Oh, okay, all right, thank you.
You're welcome.
1, 2.
Okay, so I'll share my screen and then we will start with ELB. Okay. Well, since we've already had a demonstration on ELB and ASG last week, I believe this section would be more interactive. William, are you exercising or something?
Yeah, I can hear 1, 2, 1, 2.
Oh, okay. Okay, so what do we mean by scaling? Emmanuel Kuru.
Scaling means meeting demands of customers. You can either scale up or down, depending on the product. Thank you.
All right, thank you, Kuru.
You're welcome.
So yeah, the rate at which end users or customers are using our app, the rate at which they are accessing your applications, you would need, or sometimes you would need to scale to meet that demand. And when we talk about scaling, it's you're either scaling in, which is reducing your capacity, or you are scaling out, which is increasing your capacity. Okay, so the ability for you to increase or decrease your compute capacity to meet fluctuating demand. So you are having probably you paid for ads on some sites, and then you are getting a lot of traffic coming in. You would want to scale out because your demand has increased. And then when it goes back to a normal day, or probably a better version of your app has been launched by a competitor or something, and then you will need to scale in, then you would also do that as it demands. Okay. You can scale manually or automatically. So manually is when you have your CloudWatch metrics monitoring, or you yourself are monitoring. And then when you realize that your CPU is getting overwhelmed, then you go and provision a new instance, and then you register it as a target for the load balancer and all of those things. That's one way manually, which we know is not encouraged. And then we also have automatic scaling, auto scaling, where you put measures in place so that as these changes happen, these things would be done on your behalf. So a typical example is a tax preparation company. So when the deadline for paying of taxes, which is the 15th of every month, is getting closer, you get more users logging on to pay their taxes, okay? But when it's not yet that time, you know how people can be, they want to wait till last minute to do what they have to do. And if it passes the deadline, they'll receive a penalty. So the money is going to go up. So that's peak period. You realize that everybody will be trying to make their payments, right? On 16th, 17th, you see that it has gone back to 0. They're waiting again to file when that deadline is near. So in a situation like that, you would want to make use of auto scaling. So when this peak period isn't in use and it's just the normal traffic that is happening, then what would you want to do with those many servers that you provisioned when it was peak period? Definitely you would need to cut down on them or destroy them so that you could save cost. So if you have a knowledge of your peak periods, you can be able to use that to configure your ASG, your auto scaling group, so that it happens according to your needs. And you can also use monitoring to scale out servers when critical resources such as average CPU utilization across the fleet become constrained. If you want to get like a mental picture into CPU utilization, you could, a lot of us use Windows laptops, so you could open your task manager and then just open different programs on your machine, and you'd realize that your CPU utilization is going higher and higher. So out of the 100% you have, you'd be consuming more and more. So that's kind of the same idea when people log on to your application, they're logging onto your server to come and perform some task or to come and get some function from there. And if a lot of people or a lot of tasks are going on your server, then there might be the need for you to scale up, because your resources, such as your CPU, are becoming constrained. So the load on them is more and more. And when it's no longer a peak period, you should be able to scale in back to your baseline. Baseline is like the normal day or the normal traffic that you receive every day, okay? So you can specify your maximum, your minimum, and then your desired capacity when using ASG. So some benefits are that your application would be fault tolerant. This means that whenever components or servers inside of your application are overwhelmed, it doesn't throttle, it doesn't stop working, it doesn't stop responding to requests, but it's because another server would be provisioned to help it carry the load. Your application would still be able to go on and work. So that's high availability. With fault tolerance, if your server should go down or it should develop any faults, if a component of your server should fail, you know that autoscaling group is going to provision another one in its place. So your application is fault tolerant. Faults do happen, but they do not stop the running of the application. And also performance. If your resources are being overwhelmed, it's likely that your server will not be of the best performance. Sometimes we have a lot of tabs and a lot of things opened on our machines, on our computers, and then you realize that the computer will be running really slow unless we restart it or unless we close everything just to free up some space on the RAM, or just to reduce the number of programs that are running at the same time, okay? And we find that usually that helps with how slow it's running, it improves the situation. Another one too is cost optimization, where you are able to save money because you don't have resources that are sitting idle inside of your environment. 1 second. Yeah, so if it's no longer your peak period and you still have those servers provisioned, you are not saving costs. So it will be a good idea to have them destroyed so that you can save money. Okay. So the components for scaling, we have routes 53, ELB, and your auto scaling group. So what route 53 helps with is that it gives you it gives your users a single point of contact. So let's say your users are trying to reach Kuru.com. Okay, now inside of AWS, the Kuru application is running on these 5 instances. Now your users are using Kuru.com to reach these 5 instances. So with the help of Route 53, so Route 53 is AWS's domain name service, and what it does is that it helps you to get a DNS name, a domain name. So how we see facebook.com, how we see google.com, those things. So your app too would is likely to have a domain name. I remember when we were hosting the static website in S3, I believe Penty was asking if we could shorten the URL or make the URL look more professional, because when because when he gives that URL to his employers, well, he didn't want to give that S3 static website URL to his employers. He wanted something more professional, or something that looked cleaner, okay? And then I remember mentioning that he could use Route 53 for that. So you could register your application or your site to a domain name. So when people look for penti.com, it will bring them to that site that you want them to reach. So if people are accessing their application, their domain name or what they type in their browser address is what is provided by Route 53, but that is if you have registered your kuru.com, facebook.com or whatever.com with Route 53. So by default, when you provision an elastic load balancer, you get a DNS name that is not so what's the word? It doesn't look so professional. It's not a good idea to give your the default DNS name that you get when you create the ALB. It's not a good idea to give those out to your, what are they called? To your end users. So it's best to map this DNS name to your actual DNS name, which could be recordingapp.com or something of that sort, so that when your users access that DNS name, it will bring them to the ALB, and then this ALB is fronting these your 5 instances. So it's just a better idea. It's safer, more secure, and more professional to go through this route and for your end users to come and meet these 5 instances. The worst and the worst of them is when you give out your is when you give out your instance public IP address. That's like worst. Okay. Daniel.
Yeah, Abuja, please, good afternoon.
Good afternoon.
Yeah. So please, I wanted to find out if the Route 53, is it, is it free, or are they going to debit it from your, your credit accounts? That service.
So it depends on what exactly you do with it, but most of it is paid.
Oh, okay.
I think if you already have the domain name, so AWS isn't the only domain name service provider, okay? You can use GoDaddy, Wix, those things. So if you already have your website name, then the cost is cheaper. But when you pay for a domain name from Route 53, I think it's is it $12 or $11 per year? I think it's Odum.
Well, sorry, it depends on the name you choose. In my case, I chose .site, okay? And I think I'm paying $7 or so for the whole year. But if you go for .com, sorry, and depending on which one you choose, you can pay up to like $14, or sometimes you get a discount and you pay maybe around $11, $12. And I use Namecheap. So like you said, there is GoDaddy and other ones as well that you can use. Even AWS also has one, Route 53. You can get a domain name from them, but DS is normally on the high side. So that's what you can make do. All right.
Good. And does it mean that they are going to debit it from, AWS account? If like the way you are saying that Route 53 also have their DNS they are selling. So when I purchase it from there, is it that they're going to debit it from that account, or have to use my bank
it's from
account
your
to purchase?
AWS account.
Oh,
okay, it's from your bank account. I don't think it's within the free tier.
But imagine you have like maybe 300 USD.
Yes,
credits.
so it will come from there.
So, I think he was asking whether you're going to pay it outright or they will deduct from your account, right?
Your account. Yeah, good.
For that, I can't tell. I've not done that before, so I don't know whether it's
No, that's
outright
okay.
or they'll bill you at the end of the month.
Oh, okay. Okay.
I would say maybe we can use the is it the cost calculator?
Okay.
Oh.
So, Daniel, so your question is if you have to pay it outright or they will deduct it at the end of the month.
Ye-
Maybe like
Yes,
they
please.
do
And also,
for other the other services.
yeah, so that was one of the questions. Also, like you also clarified it that the service is not free. Like I mean, the Route 53 usually.
Okay.
Okay, so Akosia, please let me clarify this. So Daniel, see the
Yeah.
Route 53, it depends on what exactly you are using it for. In my case, I have my domain name outside AWS, okay? So anytime I
Okay.
use Route 53 to do the DNS routing for me, okay? I've even already set it up there with the certificate, everything. And every month I pay 50 cents. Every month is 50 cents. But if you are to get a
For
domain
the
name from
rerouting.
yes,
Okay. Okay.
yes. Every month, 50 cents. Yeah, that's what they charge. But if you were to get the domain name from them as well, then probably you pay more. The domain name is,
More.
I think, annually. They charge per year. So that's it. All right.
Oh, okay. Okay. Great. Great. Thank you very much.
All right, you're welcome. And I'm seeing here that you could have a free tier of 10,000 records. Well, we will treat browse 53, I think after this one. Yeah. So we'll look at the details of it soon.
Okay. Thank you very much.
But yeah, it's paid. You're welcome. But so if it's just your ELB that is fronting your instances, that's DNS name that is not to be given out, or that is not so appropriate to give out, that one's free. Okay. So a lot of the websites that we visit or a lot of the apps that we visit, they have not just one server, like multiple servers running them, okay? And what's the way that you're able to aggregate all of them or make sure that whenever somebody accesses your site, they are coming to one of your servers is by the help of this load balancer that you use to front them. So one of the services that you use to implement scaling in the cloud is the Elastic Load Balancer. And it automatically distributes your traffic across multiple targets like EC2 instances, containers, IP addresses in one or more availability zones. So when you are configuring a load balancer, you will need to have at least 2 availability zones. So when you're making the configurations, you need to have at least 2 availability zones that you want the ELB to be routing traffic to the resources inside these at least 2 availability zones. And an additional feature that ELB has is that it's able to monitor the health of your targets, and it routes traffic only to the healthy targets. So if something is going on inside of your instance, so for example, you've had to shut down to make some updates, or your instance is under an attack, or something is going on, probably the application that is supposed to be serving clients is not functioning well, ELB knows to not send traffic or to not direct your end users to that application. And with the help of the autoscaling group, it is able to scale your capacity in response to the changes in incoming traffic. So this is an example of how the load balancer works. Your end user, your client, is accessing the load balancer. So in this example, your clients probably have your load balancer DNS name, and then as they are accessing it, the load balancer will decide to route them. So by default, it does it in a round robin fashion. So the first person to come would be directed here, second person here, third person here, fourth person comes same way. Okay, Dennis.
Yeah, so please, the description about the load balance and what it does, I saw the it's monitoring the health of the instances, and in the demonstration too, I saw Iman say a little about that. So I wanted to find out. I realized the health, it checks sometimes the compute. You can set some metrics in terms of the compute, and then maybe the memory and all that. But aside you choosing like what it should monitor automatically, what are the resources it will be monitoring?
For it to get information about the health check.
Yes.
Well, it doesn't exactly monitor your resources. What it does is it sends some traffic to the instance. So if the instance is able to respond to that request it has sent to the instance, then that means the instance is what's it called? Is up and running.
Oh, okay. So more like ping requests, like we did.
Yes, something of that sort.
Oh, okay. All right. Thank you.
You're welcome. So your instances are registered to the target group, and as and when traffic comes from your clients, the load balancer is going to be distributing this traffic as evenly as possible as it can to the various instances inside your target group. So it works like a traffic director. So we could think of it as what's it called? The traffic directors that we see at the traffic lights. Okay, so this person just indicates go this way, or even the security man at the bank. Okay, so these are some use cases for load balancing. It's
Filling station too.
yes, filling station too. Thank you, Ruben. It helps you manage your applications more securely. So it provides a secure access through a single point. So as I mentioned, it's really a bad idea to be giving out your the IP address of your server, of your particular server. So the load balancer would front this, and then everybody who has access to those servers can go through the load balancer. So if there's any traffic or any attacks or whatever, it meets the load balancer first. And then the load balancer is, you don't do any management on the load balancer, no updates, no nothing. You just provision it, and AWS takes care, it's a managed service. So AWS takes care of everything about the load balancer. And it also helps you to decouple your application environment. So you're able to have multiple instances instead of you just having one server that does everything. Thanks to this load balancer, you'll be able to have multiple servers because this load balancer makes sure that your users are coming to the same endpoint. They're coming to the same place when they are trying to access your app. And it also provides fault tolerance and in the sense that if anything should happen to any of your servers, there is another server that's the load balancer can route the traffic to. As I mentioned, you should have at least or you should have resources in at least 2 availability zones before you can make use of the load balancer. So if your resource in one availability zone is down, then the other one will just continue to serve your clients. And it's also expansive, so it helps you to increase your elasticity and scalability. So elasticity and scalability. Okay, so some additional features that the load balancer has, it provides you with high availability, as I mentioned, multiple availability zones. It also has the health checks feature. Jacobo.
Yeah, so I want to ask, is the previous slide, is the target group the same as the auto scaling group? The previous 2 slides.
Well, yeah.
Okay. Thank you.
You're welcome. So it also provides health checks where it sends a request to your instance or to your server, and your server has to respond with a 200 status code. And if your server responds to the load balancer, then your load balancer knows that your server is up and running, and it would send traffic there. So what happens is these health checks are automated. They come with the load balancer. So periodically, the load balancer by itself will just check on your servers to make sure that they are up and running, and you could configure the time or how often you want the load balancer to be checking on these things. Because I think it's between 60 and 300 seconds. Because if you set the time to be really long, it will take a long while before the load balancer realizes that something is wrong with one of your servers. And if it's really short, then that's just, well, a lot of things happening on your inside of your infrastructure. So you look at what you need and then you set that time. I believe by default it's about 60 or 120 seconds. I'm not so sure. And it also has security features and TLS termination. So then you could attach your certificates, so your SSL TLS certificate, to the load balancer so that the decryption and then so that the decryption of the traffic happens on the load balancer. So as and when a request comes in, the load balancer is able to tell if it's a secure request or not, and it is also able to inform your users about if they are accessing a site that is that has the S. So whether it's HTTP or HTTPS, the load balancer is able to handle the decryption of the traffic that's coming in. And when it comes to the OSI model too, there are types of load balancers. We have the one that works at the layer 4, and then we also have the one that works at the layer 7. Layer 7 is the application layer. So we know that would be the application load balancer that works at layer 7. And then layer 4 is the transport layer. And layer 3 is the network layer. So the network load balancer works at layer 4. And it also has operational monitoring. So from time to time, the load balancer checks on your resources to see if they are up and running and if the load balancer could forward traffic there. You can also integrate your ALB to work with CloudWatch metrics, and that's to request tracing. And you can also use them to monitor your application's performance in real time. So as and when the load balancer spots that there is an issue with the application, you would know about it. Derek, I'm okay. I think my voice is just down a bit today. Sorry, guys.
That's fine.
So to discover the
No,
availability, did someone say something?
Oh yeah, sorry, please you can go on. When you said like you're done, I was like, it's not fine.
It's not what?
I mean, like Dennis was like, it's fine. And I was like, no, like I want to see the madam in
So
tablets,
someone
strength.
just drew my attention that I sound different today. So I was just apologizing. I'm okay. Okay.
Okay.
So to discover the availability of your instances, the load balancer periodically sends pings, attempted connections, and requests to your instances. And these tests are called health checks. So when it sends the ping and your instance is able to respond, then it knows that your instance is up and running, and then it would go ahead and send the traffic there. So guys, we've done pinging, right? So when you think of health checks, think of it to be something like that. The requests are sent, and if your instance is able to respond, then the load balancer knows that your instance is okay. It's also another way for you to tell that your instance is up and running. Okay, so inside of AWS, there are 4 types of load balancers. And was it the security week? There was a week that we looked at protocols and ports and those things. Do you guys remember? Looked at HTTP, TCP, and we looked at the difference between UDP and was UDP and is it TCP? One of them establishes a one of them establishes a
Yeah.
connection, one of them doesn't. Yeah. So those are the things we'll be looking at or we'll be reminding ourselves about today. Dennis.
Yeah, so I just wanted to share and firm up something I'm learning recently, and I want to relate it to the benefits of maybe moving a business to the cloud. When you shared on the previous slide, that's the ping request, the load balancer sent to your instance. So recently I stumbled on a YouTube video which was talking about the security issues with our phones, like in terms of the Wi-Fi request that our phone sends out to connect to different routers. And they said it's a security issue because a hacker could be in the middle and pose as the router your phone is trying to connect to, and your phone will connect to the malicious, network rather than the actual network that it's looking for. So, I mean, the physical sense, I'm looking at, let's say, if we had a physical load balancer which was supposed to send ping requests to actual servers, someone could physically be in the middle somewhere and attract these requests and pose as if it's the actual server. And I mean, it will make DDoS and all these man in the middle attack much easier. But then on the cloud, I don't think the hacker could find, I don't know which AWS data.
So the cloud works with internal, what's it called? Oh, private IPs. So the cloud works with private IPs, and unless the hacker is able to get the private IP address of your of your instances, they wouldn't be able to make that request. So that's why it's always encouraged that you provision resources inside the VPC, because that's the only way that your resources are going to have a private IP address. There was it assignment 7, that assignment that we had to do, and we had to ping our instance inside the private subnet. That instance didn't have connection to the internet, but then we're still able to ping it because the connection came from AWS's internal network. So yeah, that's a security feature that AWS helps with, because the hackers do not even have your server's private address and even try to mimic it or ping it or whatever.
Yeah. All right. Thank you.
You're welcome. And I saw John Yelbert's hand up.
Yes, Akosia. Hello, good afternoon.
Good afternoon.
Yes, I was just going to ask if there are two words I have seen floating about, whether they are actually interchangeable or similar. We're talking about the load balancer, and we are talking about the fact that it also it enables scalability, that's scaling out or scaling in. And the service itself is called Elastic Load Balancer. And I understand elasticity within the Amazon frame implies the thing being able to stretch and then reduce. So I'm asking, is it that scalability and elasticity in this sense are interchangeable words that can be used, interchangeably? Thank you.
Okay. Right. Thank you for the question, John. So elasticity would refer to scaling up and down. So elasticity is more vertical scaling, and then scalability is more horizontal scaling. So the load balancer is able to the load balancer is elastic in the sense that when you give it just 2 instances or just 2 resources inside of the target group, it would be able to handle it. And when you give it 10, 15 instances inside of the target group, it would also be able to handle it, because the load balancer is able to scale vertically. Let me put it like that. So the load balancer itself is able to scale vertically, and so you don't need to provision another load balancer. Just that single load balancer can handle a smaller number of resources, and that same load balancer can also handle a larger number of resources. Is that okay?
Yes, thank you, Madam Akosia.
You're welcome.
So, Madam, well, should I bring not?
You can go ahead. Was that Daniel?
Yes, please. Yeah, so please, I'll just find out. So with the vertical scaling, meaning you can only increase, like, the vertical scaling you talked about just now, meaning like you are increasing something, more of like adding something. I don't know if you're like adding the RAM, adding CPU. Is it what you mean by
So
vertical
I think
scaling?
you can both add, yes, that is vertical scaling. So you can both add or reduce depending on the resource that you are using, depending on the service that you are using. But in load balancers, we don't take care of that. AWS manages all of that. So if AWS believes that the CPU of the load balancer needs to be higher, then they automatically provision it so that it can scale, what's it called? So that it can distribute to more instances without us even having to configure that. Yeah. So it's increases its performance and decreases its performance on its own without us interfering. That's the load balancer.
Okay, okay, yeah, yeah. And okay, okay, we know, okay, it's clear as you go. So meaning that if in a case that maybe there's a lot of traffic, or maybe on a web app of yours, a lot of traffic is on it. So meaning that using the LED, meaning if the traffic that day, I mean, is very high, so meaning that that's to automatically provision a lot of EC2 instances. So I mean, it can distribute the traffic to. But does it mean that the cost is also going to increase for that particular, I mean, day or something?
So you don't pay for the load balancer. You only pay for the instances that you
Instances.
that is fronting, but you don't pay for the load balancer.
Good. Okay. Okay. So I wanted to, it's monthly, I mean, okay. Yeah, please, I get it now. Fine. Yeah, thank you.
You're welcome. Ruben.
Yes, madam. Good afternoon once again and welcome. The question concerning Brother John's question, the two words, the elasticity and the scalability. So for my opinion, I think they are synonyms because I think when you consider elasticity, the explanation is the same as the scalability.
Ruben, please
That
hold
means,
on.
okay.
What's his name? Daniel. So I'm just
Yes,
looking at
madam.
the documentation and I'm seeing that you are charged for each hour or partial hour that an application load balancer is running.
Oh, okay.
Yeah, so I actually didn't know
Oh,
that.
okay. So, okay. So, okay, okay. Meaning, if you have, I mean, you're receiving high traffic, meaning that the cost is going to be very high. Like just like the instance, you made an instance that imagine like a bank at the end of the month, payments have to be made, then people are withdrawing or trying to have access, meaning that the traffic is going to be very high. So in that instance,
Yeah, I
their
think your
price is
costs
going
is
to,
also going to go up. Yeah.
yeah, okay, okay, okay. Thank you, ma'am. Thank you very much.
You're welcome. Ruben, please go on.
Yeah, thank you once again. So elasticity is also determined by the demand. If the demand increase, that means scale out. When the demand decrease, then scale in. So there are synonyms. That's one is, I say, maybe elasticity is the name of the service. And in order to explain what elastic load balancer is, that means you use the word scalability. That means ups and downs. So I think they are synonyms that we can apply together or in a scenario like this. Thank you.
All right. Thank you, Ruben. So I remember when I was preparing for CCP, there was this question that, like, so this elasticity and scalability, they used to confuse people. So sometimes it will be the same question. And if you see both elasticity and scalability, I think the answer will be like scalability. But if it's the same question, you see only one, then the answer is one of them. So when we start exam prep, we'll see like all these things and then we'll be able to get the actual understanding. How I look at it is elasticity is up and down, and then scalability is in and out. So in that sense, vertical and horizontal. So we're going to see all of that. Thank you, Ruben. Dennis.
Yeah, so I wanted to ask that is the ELB in itself an instance or like a server? Since you
I
said
think it is. I think it is because a lot of the services that AWS offers, they run on EC2. They run on service, but that's under the hood. So with the way Lambda is platform as a service, for instance, when you go there to run your code, definitely it's running on an EC2. But because you don't manage it, it's like it's not really it's not there. I don't know how to explain it. Yeah, so I believe the ELB2 is an application that is running on a server, just that we don't see it.
Okay. Yeah.
Terry,
Yeah, good afternoon.
good afternoon.
So for me, I think scalability and elasticity, and they are different in such in a way as scalability refers more about a software system, whereas elasticity talks about the hardware layer. So when we're talking about scalability, you're talking about the ability of a software system to process higher amounts of workload on its current hardware resources without application service interruption. But when it comes to elasticity, the ability of the hardware layer to increase or shrink the amount of physical resources fed by the hardware layer to the software layer. That is how I see it. And I
Yeah,
think
that
it's
makes
quite
sense. That makes sense too. Thank you, Terry.
But elastic IPs have nothing to do with the hardware, so it confuses me.
Elastic IPs.
I know they're like if you want to get a dedicated IP for your
Yeah, for your instance or something. Yeah. Well, AWS has this elastic weight attached to a lot of their services and features. Even EBS is Elastic Block Store. And so yeah, maybe depending on the service that it is, it might differ. But the main understanding of something being elastic is it can stretch to be as big or as much as you need, and it can shrink to be as small as you need. That's the idea, like elastic. Those of us who wear elastic clothes, is that not the idea?
Exactly.
Yeah.
Anyone know you have said it.
So it's only elastic clothes. That's not the explanation.
Hey,
So
Gift, what
when you need a small person to wear the clothes, they would be able to. When you need a big person, it will stretch to fit the big person.
The skinny jeans.
Mm-hmm.
That's
Okay.
Denny's favorite.
Hey.
Hey.
So with the types of load balancers in AWS, the oldest type of load balancer is the classic one, and then more recently, network and then application load balancers were also introduced, and then gateway is the newest load balancer that was introduced by AWS. So I believe the classic load balancer is no longer supported. So let's start with the application load balancer. We know about the OSI model, and the application load balancer operates at the application layer of the OSI model. It provides load balancing for HTTP traffic, HTTPS traffic, and okay, I don't know what Google Remote Procedure call is, but if your end users need to access your website using port 80, HTTP or HTTPS, these two protocols are the foundation of websites. So that's how your users or people will be able to access your website through one of these two protocols. So when you have you have your website up and then your users need to access your application, you would usually give them the HTTP, or they would usually access through the HTTP or HTTPS endpoint where your website is being served to them. And health checks. So with the application load balancer, you are able to perform health checks, and they are recommended for when you are using your resources and when your resources have been provisioned inside a single VPC, because they would be able to get the internal IPs and then they would be able to work with them inside of your VPC. They could be internal or external. External load or internet-facing load balancers receive the traffic from the internet and route to your private resources, and then the internal-facing ones receive traffic from your other resources in AWS, and then they route to your internal resources inside the VPC. And a lot of websites and mobile apps that's running containers or on EC2 instances all benefit from the use of application load balancers. Gateway load balancers are detours. Okay, so let's say I'm trying to move from this deep blue line to this cyan line over here. So on my way, I could just come straight. That's if I'm using an application load balancer. If I'm using a gateway load balancer, when I get to somewhere here, I will be made to branch. So take a detour, take branch away from my main route so that I could perform something before I continue to my main destination. So that's what the gateway load balancer does. It provides deep packet inspection. It would inspect the traffic, it would inspect the IP addresses, those things. So whatever traffic that is coming in to your instance, you would want to use the gateway load balancer when you want to inspect the traffic. You want to get some additional information about the traffic before it reaches your instances. So I think there's a more vivid image when we scroll down a bit. So you would be able to get more information about whatever traffic that is coming in to your load balancer. So if it's something harmful or something that you do not want inside of your environment, the gateway load balancer will drop that traffic and it would not come to your instances. And if it's inspected and it's non-malicious, it's legit ideal traffic, then it will be let into whatever endpoints that it came looking for. Then we also have the network load balancer, which is a really fast mechanism. It has really high performance, and you would need a static, and it offers you a static IP address for your application, and it operates at the transport level of the OSI model. So we know that the OSI model is responsible for how data is transmitted over networks or over the internet. Okay, so the network load balancer is used for TCP traffic, UDP, and TLS. And the classic load balancer, which is no longer in use now, when it was being used, what it does is it has the functionality for both the application and then the network load balancer. So at that time, this gateway wasn't in use yet. So it combines the protocols for both of these application and network load balancers, and it is able to route the traffic for these various protocols. And it's not even encouraged to be used as at now, but I believe when we would see, when we are trying to provision a load balancer, we'll check if the classic option is there or not. Last I heard it was discontinued. So yeah, because it combines,
like they have taken it out.
They've taken it out. Okay.
Yeah, it looks like.
So because it combines both HTTP, HTTPS, and TCP, UDP traffic, it operates at both these layers, both the transport layer and then the application level layer. Sorry about that. Okay. Let's go here. All right, so this is a link for a side-by-side comparison of the features that are available for the three load balancer types. So the application load balancer, it works with you're able to configure path-based and host-based routing. Path-based and host-based routing is when the traffic that is coming in, so the end users on your website, you give them a path, or you know of a path that they would need to use to get some resource. So you configure inside of your load balancer that if they are coming through this path, then they should be directed here. If they're coming through this path, they should be directed here. I don't know what example I can give. Okay, so let me go to an e-commerce website. See if I can demonstrate this from there. Okay, so when you come to this website, for instance, let's pay attention to this the address bar. So when you click on supermarket, we see that the jumia.com.gh has changed to groceries. I mean, groceries has been appended to it. Okay, when we click on computing, we see that computing has been appended to the website. So these sites that we are visiting, or these pages that we are looking at, they are all on the same website, but then they all have different paths that we take to get to this website. So a strategy you can use to reduce the load or to distribute the load on your various instances is to configure path-based routing inside of your load balancer. So you'd say that if any traffic that is coming in is coming, the content is this /computing, then the person should go to this server. If the content is /groceries, the person should go to that server. Okay, so you'd be able to have your application load balancer route different users to different servers based on the content of the path that they are coming with, or the contents of their path. And the application load balancers also have native IPv6 supports. I've said this before, that with the IPv4 addresses, the maximum number of IP addresses that are available are about 4 billion. And then the human population is also about 8 billion. And we understand that one person can have multiple devices, and each of these devices would have their own IP addresses. Your router has its IP address, your computer, all those things. So the IP addresses are getting maxed out. So IPv6 introduces more bits, so you are able to get more options for IP addresses when you use the IPv6 IP addressing system. So application load balancers accept they support IPv6. IPv6 isn't really, I won't say it's really common yet, but there's just a number of people that use them. So if people need to route traffic to their IPv6 resources, then the application load balancer supports them with that. But we so far have just been dealing with IPv4. And Dennis.
Yeah, so with the Jumia example, I wanted to ask, so does it mean that like each category on a website has to be hosted on a different server, like the demonstration you just did?
Oh no, they don't need to.
Oh, okay.
So some of them could share. Let me see. Yeah, so they could share some of them, about 4 of them on to one server, depending on the kind of traffic or the number of people they have accessing that endpoint of theirs, then they would configure it that way on their load balancer, just to distribute the traffic.
Yeah, okay. All right.
So application load balancers also support dynamic ports. You are able to configure port ranges for certain, so we know that what's it called? We know that the end users use ports 80 and 440 to access your website. Okay, so you can also configure your load balancer to listen on a particular port. When we say listen, to pay attention on a particular port, and to prevent port clashing. There's a technical term for it, like making sure that one port isn't being used by multiple services. So the application load balancer has that configuration that you can put in. You would route your traffic to go through different port numbers. And they also have additional supported request protocols. So okay, I'll come back to that. With deletion protection and request tracking, you are able to set a deletion protection on your load balancer so that whenever or if ever it should get deleted, you know that it was not done by mistake, because we know about deletion protection when we're looking at Ruben's environments the last time. So before you delete, or before you're able to delete the load balancer, you need to make sure that you have disabled that deletion protection. So there's no way that you can say that it was a mistake because you had to delete that, sorry, disable that before deleting it. So the additional supported request protocols refer to the other protocols that the application load balancer might need in addition to the HTTP and HTTPS that we know about. And it also has enhanced metrics and access logs. You are able to monitor your load balancer so that you take action as needed. And the access logs to give you information about what is going on inside of your load balancer. And it also offers targeted health checks. You are able to monitor the health of your resources independently. And there's a way to also aggregate the health checks, and then you are able to know if overall your environment or your instance is doing well or not. So an example of the application load balancer in use. Okay. So in this example, we can see that the load balancer is routing traffic to the backend. So the backends are your EC2 instances or your resources that your clients are trying to access. And you need to configure listeners for the load balancer. And you'd also need to define rules to direct how the requests that the load balancer receives are routed to the backend targets. And you would also need to configure the health checks So when a request is received, so the listener is always looking out for requests being made to the load balancer. So when it receives that request, it evaluates the rules that you have, and based on those rules, it would route to the appropriate target. So the gateway load balancer, it provides load balancing at layers 3 and 4, which is the network and transport layers. And all the layer 3 traffic is passed through a third-party virtual appliance. So this appliance could be an intrusion detection system, or a deep inspection system to inspect whatever traffic that is coming in. So when your clients or your users send in the traffic, the gateway load balancer forwards it to this third-party appliance that will check before sending it back to the load balancer. So if it's problematic traffic, then it drops it. If not, it sends it back to the gateway load balancer, and then the gateway load balancer would send it to where it was destined for. So when it gets here, it takes a detour to have the inspection done before it's able to continue its journey. And it supports IP protocols, and it provides deletion protection and request tracking. You can track the requests that we made to the load balancer or to the resource through the load balancer. And it also provides enhanced metrics and access logs. And it also provides targeted health checks. So the gateway load balancer would only forward healthy traffic to the available destination. The network load balancer. It's suitable for sudden and volatile traffic patterns, and it provides a single static IP address per availability zone. If your application requires extreme performance, then the network load balancer is good for you to use. So if we remember lessons on TCP, UDP, we mentioned that UDP, it's connectionless. So UDP is quicker as compared to TCP, because TCP, you need to establish a connection before. So the network load balancer it has been made in a way that it can handle millions of requests at the same time. So if you are expecting a lot of traffic, or you need that speed for your environment, it's the network load balancer that you would use in that case. And you should also pay attention that it works at layer 4 of the OSI model. So if you have certain best in traffic, so probably you just have about 100 traffic coming in right now, but all of a sudden it goes to 900, all of a sudden it goes to 1,000. That's kind of use case. You'd be looking at the network load balancer helping you out. And it's also able to filter the metrics based on availability zones. The classic load balancer Dennis.
Yes, so I wanted to ask about the request. Is it like at a go, like maybe 1 million people connecting at the same time, or it starts counting one by one from the day you provisioned it until the 1 million?
At the same time, so 1 million per second.
Oh, okay. Okay. Yeah.
So the classic load balancer provides access to servers through a single point, just like the ones we've seen already. And it also helps decouple your application environments, provides high availability and fault tolerance, and it increases elasticity and scalability. So thanks to you having the load balancer, you'd be able to have multiple instances and have your users reach them through that single endpoint. There are some newer features that have been added in recent times that the classic load balancer doesn't have. And AWS has stopped using the classic load balancer, and the only instances that you might come across would be when a company is trying to migrate from using that classic load balancer to a more modern load balancer. So some people joined, or some people have been using AWS for a long while, and then one of the well architected framework ideas or concepts that we looked at is to improve with time. But there are a few people who still haven't. So if you should come across any classic load balancer use case, it would be for the fact that they are moving to a more recent load balancer option. Dennis, please, is there still a question?
Oh, no, I think I should lower my hand.
Yeah. So which load balancer would be appropriate for a website? Question number 1, Albert Adai. Emmanuel Janin. Emmanuel Auku. Yes, John.
Please, I actually wanted to ask a question earlier on, but because you
Okay.
were explaining something, yes, I decided to wait for you to finish.
Okay, go ahead.
So we've seen the 4 different types of load balancing or load balances. And the classic one had been maybe decommissioned or removed from the system. But is it that the configuration that are done that makes one particular load balancer becomes one type, or that depending on the service you are providing, you end up providing, if you feel that you need an application load balancer for maybe your website, then okay, but I will also need, because within my VPC, I also have some resources that runs maybe a different service, and so then I have to provision maybe gateway load balancer for it. Does it mean that you are going to provide different types of these load balancers, or that it is actually by the configuration that you would make? So then you can actually extend the configuration and make one particular load balancer become both application type load balancer and a gateway type load balancer? Or how are we doing that?
Yeah, so you can yeah, so it depends on the function you are trying to meet. So inside of AWS, you can use different services to be able to get you the security features you're looking for. So if it's through the gateway load balancer that you want your traffic inspected, then you go for that option. But if you don't want to have it done through the load balancer, you can just use the IDP that we saw, the intrusion detection system for AWS, or the AWS firewall or some other service. So it depends on the use case that you have. If you have, yeah, it depends on the use case that you have. That's what's used to go for the load balancer type.
But not that you can have one load balancer and configure it in such a way that it will perform different load balancing functions.
So with the use of route tables, you might be able to do that, but that will require more additional work. But you can use route tables to configure your load balancer to act in a different way. And the load balancer rules too are also available if you want to tweak or you want to make some changes to the default way that the load balancer is configured.
Okay.
Yeah.
Okay. Thank you. That's what I wanted to ask earlier. Even though there is another question I wanted to ask. That load balances are tied to let's say availability zones. Said a region, and then you do it with two availability zones. If I'm right.
Yeah, you're correct. You need at least two availability zones to provision an ELB.
Okay, but it must be in the same geographical region.
Yes, of the same region.
So I was just thinking. So you have some instances provisioned within this availability zone, and then you provision other instances in another availability zone. So where do you place the load balancer?
The load balancer is not AZ specific. So as long as it's in the same region with the instances in the various availability zones, they can see it and use it because all of them are in the same VPC.
All of them are in the same VPC.
Yeah. And VPCs are region bound.
Okay. All right. So I understand. So the VPC is in the region, but within the region are availability zones.
Yeah.
So you can now position your resources in two different availability zones within the VPC, and then the load balancer is within that region. So it will see them in the region, wherever availability zone you have placed them in, and then function as it should. That's right.
Yeah.
Okay. Thank you.
All right. Thank you, Sujan. Hi.
Yeah, sorry. You called my name. I was trying to, I think I had a network problem.
Okay. Which load balancer would be appropriate for a website and why?
I think the application load balancer, the ALB,
Okay.
will be application load balancer.
Okay.
Because, like, it provides advanced requests that, like, target delivery of modern application architecture, like HTTP and HTTPS traffic route.
Okay. Thank you. Yeah, so I mentioned that because of HTTP and HTTPS, these protocols is what websites use for their communications. Then an application load balancer would be a good choice to use for your website. Okay, so question 2. I think I would call the person before I mention the question. Hassanatu.
Hello.
Oh, okay. Question 2.
I think the network load balance.
Okay. Okay. So the network load balancer is suitable for bustable applications because it's able to handle millions of requests per second while maintaining a very low latency. So it's optimized to handle sudden and volatile traffic patterns. Okay. So if we want to make use of scaling inside the AWS cloud, what are the other services that we would need to use with our instances? What are the other services? Cool.
Please, we have the Route 53.
All right.
Okay.
The elastic load balancer, the EC2 scaling groups.
Thank you.
All right. Thank you. Thank you, Kuru. So yeah, Route 53 would be able to give you a decent or a professional domain name. Okay, so you'd have your end users visit your website with jennifer.com or kuru.com or wuku.com, those things. So the name of your app, okay. So Route 53 will provide that for you. And then when your users visit that DNS name that you provided to them, it's the load balancer that they would come and meet. And this load balancer is fronting your auto-scaling group, which has your instances in it, which has your instances behind it. So the load balancer would be able to route the user who is coming in to one of your servers or one of the targets inside of the auto-scaling group. Okay. Dennis, please, is there a question?
Yes. So I wanted to ask, could you use like more than one load balancer for a project?
Yes, you can.
Okay. But the question one, I was thinking, you could use the application load balancer for the front end and then the gateway load balancer for the back end of the website.
Yeah, that would work.
Okay.
Okay, there, Emma.
Yes, Akosia, please, I would like to know from the explanation that we've gotten, especially between application load balancer and then the network load balancer, does it mean that the network load balancer can replace an application load balancer?
So the network load balancer also supports or it could be configured to support HTTPS, but depending on the application that you are building, depending on the port that your users would be accessing through, sometimes even though the network load balancer would give you the high performance, you still cannot use it because it doesn't suit your use case.
So you mean you can configure it to support HTTP and HTTPS, right?
Yes.
Okay. All right. Thank you.
Welcome. Okay, so I'm still on load balancers. We will be looking at load balancers and listeners. So the components of an elastic load balancer. The rules, the listeners, the load balancer itself, and the target group, which has your instances or which has their targets. And then there are also health checks that can be run on the targets. So each listener is checking for connection requests from the clients by using the protocol and ports that you've configured it to listen on. And it forwards the request to one or more target groups based on the defined rules. And each rule specifies the target group, the condition, and priority. Whenever the condition is met, the traffic is forwarded to the target group. You need to define a rule for each listener, and you can add rules that specify different target groups based on the content of the request. And this is known as content-based routing. So the idea that we saw earlier about, so when we click electronics, jumia.com.gh/electronics. So this is the content of the request. This is the request that I made to Jumia server, and this was the content of the request I made. So based on the request, the listener would forward to the appropriate target group based on the rules. So you would be able to specify these parts or these contents, and then you also need to specify a default action. So if the user doesn't use any of these requests, okay, these example requests that are here, if they don't use any, and then they use look for something that is not here, I'll just call it this. Exactly. So if the user makes a request that is not taken care of, or is not a path that you had in mind, which page should a user come to? Okay, so Jumia has taken care of that. They will bring you to this not found page and say we couldn't find the page you are looking for. So it is good practice for the person building the app or building the infrastructure to include a default page. So whenever the client's content or the end user's content doesn't include a path that we Jumia we know about, then route the person to this server, or show the person this page, something like that. And you also make the rules in priority. So it knows which rules to evaluate first and which rules to evaluate after. So the default rule would have the highest number, which means that it's going to be the one that's going to be evaluated last. So if the request the person is bringing in doesn't match any of the content you specified, then that means they match that default rule or that last rule. You can register a target with multiple target groups. So I'm go back to the image. So this target can be part of multiple target groups. That way, the traffic that is destined for it, or the traffic that needs to appropriately be routed to it, would come to it. And every target inside the target groups has health checks being performed on them. Johnny Albert.
Hello. Okay. Yeah.
Hi.
Yes. Sorry once again. I just want to ask another question. I hope it will help me clarify a few things.
Okay.
Okay. So from the presentation we had the other time, I think Friday or yes, I think so. Yima and his group, in fact, Yima demonstrated the fact that once you have created your instance or your target group, and then let's say one of it dies, another one is automatically provisioned for you. I was thinking, so now if there are users that have connected to that particular instance, the load balancer have directed you to that particular instance, and that one dies. Now a new one is going to be provisioned at that particular moment. Then it means the users are going to lose connection to it. Are they going to be moved to another instance that is healthy before a new one comes in? And then you also talked about the fact that the load balancer is going to do a round robin thing. Put one here, put the next one there, put the next one, so that it distributes the load evenly and equally. Does it mean that it is going to now move people to other target group when one had died, whilst one is automatically provisioned, and then return them back to where they were to maintain that balance? I don't know how that is happening.
Okay.
I don't know if it's clear.
Yeah, so as soon as it happens, so depending on the amount of time that it will take your auto-scaling group to provision a new instance, but if you have at least 2 instances, the user would be routed to the other instance that is available. So with respect to the user losing their data, if the instances are using a shared volume or shared storage, that would not happen. And then another feature you can use is it's called session affinity. So when you start a session with one instance, there is a component, it's called sticky session. So there's a component that registers on the user's device. So your phone or your laptop that you're using, it would be able to save whatever progress that you were making or whatever changes that you were making on the application or on the instance. That's way when you are routed to another instance, the other instance would be able to tell that you were working on something and this is the part of the thing that you've got into. I don't know if you understand what I mean.
Yeah,
Kind of like cookies idea. Yeah.
Yeah, I understand that. Okay. And then when a new instance is provisioned by the auto-scaling group, are people going to be moved back, or now new users who may connect will now be directed to that one?
Yes.
Okay. Okay. Thank you very much.
Okay, you're welcome. Odum.
Yeah, of course. Please, I would like to throw more light on John's question. I think he was trying to paint a scenario where, let's say, the load balancer had directed the traffic to, let's say, an instance A or a web server A, and then in the process, it drops dead. In that situation, then there wouldn't be any feedback. So the load balancer would have to redirect the traffic to another one, because at any point in time, the load balancer will know which of the instances are healthy and which ones are not healthy. So at the time it was directing the traffic, it was healthy. So if for any reason in the course of maybe serving the traffic, it got dead, then it has to be tried again by the load balancer, and this time to a healthy instance. So basically that's what happens. And the users will not even know what is happening if you are using it correctly with your auto scaling. So you specify your desired amount of EC2 instances that you want to have at any given time. So let's say you specify, let's say 4, okay, and then this one dies. Automatically, the autoscaler will provision another one, keeping the number at 4 at any given time. So the end users accessing your service will not even feel it or will not even know that an EC2 instance, has died. So that's what I wanted to add to it. Thank you.
All right, thank you, Emma. So listeners, a listener is a process that defines the ports and protocol that the load balancer listens on. For you to configure any load balancer, you would need at least one listener to accept traffic, and the maximum number of listeners you can have is 50. You define routing rules on the listener, and based on these routing rules, the listener knows which targets to direct traffic to. So we know that for our applications, it would be listening over port 80 or port 440. Target groups, they contain registered targets, and then they provide support to your EC2 instances and then your ECS container instances. Single targets can have multiple target group registrations. So you could have one instance, one EC2 instance that's part of multiple target groups. And depending on the rules that you've set on your listener, traffic will be routed to that target, to that target accordingly. So this is an example of an application load balancer. I think I have this one. Okay. And comment. Please give me a minute. I'm coming. Okay. Okay. So this is an example of an application load balancer. This is the domain name where the users are accessing the sites, and then it brings them to the load balancer initially, and then based on the content of their request, based on the path that their request is coming by, they would either be routed to availability zone A or availability zone B. So we can see that the targets. So we can see that the targets are parts of let's say multiple target groups. So this orders. Okay, so this is the target group for orders. This is the target group for images, target group for registration. So based on the content of the user's request, they'll be routed to one of these three target groups. And for high availability purposes, inside of each target group, there is one instance in availability zone A and then another instance in availability zone B. So even if anything happens, we know that for sure the user is going to be routed to at least one of these targets. Okay. So how to create a load balancer? You can use the management console and you can also use the CLI. So this is the documentation of AWS on how to create the various load balancers, application, network, and gateway. The classic load balancer was retired, and anytime after December 2013, you cannot create a classic load balancer. Okay, so the process for creating a load balancer. After we treat autoscaling groups, we would look at load balancer and also look at autoscaling groups. I mean, we'll have a demonstration on both using CloudFormation. So that should be tomorrow morning. So these steps are to create a load balancer using the CLI, 5 steps. You create a target group for the load balancer. You register EC2 instances to the target group. You create a listener for the load balancer, and you verify the health of the registered targets. So the steps for or the commands that we are going to need for all of these have been provided, but we would be using a CloudFormation template for that because last week, the latter part of last week, it was one of the topics that we had to look at CloudFormation. So you guys can take a look at these steps so that tomorrow morning when we come, we would use them to some of the knowledge might translate into IAC and some of them too will not be that relevant to us. But tomorrow morning we would look at how to create a load balancer using IAC, how to create an auto-scaling group, and we would also look at how our application is going to perform or the kind of experience that our users are getting when they are accessing our websites when we have auto-scaling and then load balancing configured. Please, are there any questions for today's session? Okay. Yes, there are no questions. Okay, Osman.
Okay, so madam, that will be tomorrow afternoon, or because I understand the morning will be meeting.
Professional skills. Oh, okay. Yes, that'll be tomorrow afternoon.
Okay, thank you.
You're welcome. Dennis.
Yeah, Akosia, I just wanted to reiterate that today Francis said our deadline is not Tuesday, why? It's on Monday.
Yeah, so those of us who haven't yet completed our cases from last week, today is our deadline. So please let's try to finish the cases.
Yeah. And then secondly too, I wanted to ask a question during the session, but because of the time it ended. Concerning the internship. When I went to the page of Amalitech, the internship was only open to university like third years. I didn't see anything like maybe you want to intern as a graduate or whatsoever. But then Paul spoke of it as if it was open to everyone. So I wanted to know whether something like like that is available internally or is still restricted to third years.
Are you okay? So for the internship, yeah, I think you need to be in school to apply for the internship.
Right. Okay.
Yeah.
Just wanted to be clear.
Atosia,
Yes,
and the
Katie.
NSS people, because someone was asking me about Amalitech NSS, but I think that's closed. But
Yeah, so the
okay,
candidates had to take some tests. So they
yeah,
they did their recruitment
they've
early.
done it.
Yeah.
Oh, okay. Yeah, yeah. Okay, all right.